Imagine for a moment that you're standing on a world where the sun never rises, not tomorrow, not ever. A world where the concept of day and night has no meaning because there is only night. Eternal, absolute, and unending darkness stretching across a frozen landscape that has never known the warmth of a star. This is not science fiction. This is not a nightmare from the depths of your imagination. This is real. This is happening right now, at this very moment, across our galaxy. Billions upon billions of worlds are drifting through the cosmic void, completely and utterly alone, with no sun to call their own, no solar system to belong to, and no light to guide their endless journey through the darkness between the stars. What if I told you that right now? As you listen to these words, there could be a planet hurtling through the darkness of space just a few light years away from Earth, and we might not even know it exists. What if I told you that these wandering worlds, these cosmic orphans, these rogue planets might outnumber the stars themselves? What if I told you that despite having no sun, despite existing in temperatures colder than anything you could possibly imagine, some of these rogue planets might harbour liquid oceans beneath their frozen surfaces? And here is the question that should keep you awake at night. What if there is life out there, thriving in the eternal darkness, on a world that we cannot even see? These are not idle speculations. These are questions that scientists are actively trying to answer right now. And the answers might fundamentally change everything we think we know about where life can exist in our universe. So let me take you on a journey today. A journey into the darkest corners of existence. A journey to understand the loneliest objects in the entire cosmos. A journey to explore the rogue planets wandering alone in darkness. Before we dive deep into this cosmic mystery, let me share with you some facts that are going to absolutely blow your mind. Scientists now estimate that there could be more rogue planets in our Milky Way galaxy than there are stars. Think about that for a moment. When you look up at the night sky and see those countless points of light, each one representing a star, possibly with its own family of planets. There might be even more planets out there that belong to no star at all. Now, current estimates suggest there could be anywhere from 100 billion to 1 trillion rogue planets wandering through our galaxy alone. That is a number so vast that our human minds cannot truly comprehend it. For every star you see in the sky, there might be 10, maybe 20, maybe even more planets drifting through the darkness between them. Here is another fact that might disturb you in the most fascinating way possible. The nearest rogue planet to Earth might actually be closer to us than the nearest star other than our own sun. Proxima Centauri, the closest star to our solar system, is about 4 light-years away. But a rogue planet could be lurking in the darkness much closer than that, and we would have no way of knowing because these objects produce no light of their own. They are invisible against the blackness of space. Silent travellers that could pass relatively close to our solar system, and we might never detect them. And speaking of our solar system, here is something that should make you think twice about the stability of our cosmic neighbourhood. A rogue planet could potentially enter our solar system. It has probably happened before in the distant past, and it will probably happen again in the distant future. When it does, the gravitational chaos it could cause might reshape the orbits of planets we have known for our entire existence as a species. The cosmic ballet of our solar system that seems so stable and eternal is actually vulnerable to these dark intruders from the void. But perhaps the most mind-bending fact of all is this. Despite having no sun, despite existing in temperatures that hover just barely above absolute zero, some of these rogue planets might have conditions suitable for life. Liquid water, chemical energy, stable environments that could persist for billions of years. The traditional notion of a habitable zone, that narrow band around a star where temperatures are just right for liquid water, might be far too limiting. Life might be thriving right now on worlds that have never seen a sunrise. Now, I want you to really engage with this topic as we go through it together. I want you to think about the questions I raise. I want you to consider the possibilities, and I want you to share your thoughts because this is a journey we are taking together. So if you find yourself fascinated by what we are about to explore, if the idea of these lonely wandering worlds captures your imagination the way it has captured mine, then join this community of cosmic explorers. There is so much more to discover together, And the questions we will ask today are just the beginning of a much larger exploration of our incredible universe. Now, let us begin our journey into the darkness. To truly understand rogue planets, we first need to establish exactly what we're talking about. A rogue planet, sometimes called a nomad planet, an orphan planet, a wandering planet, a free-floating planet, or a starless planet, is an object of planetary mass that is not gravitationally bound to any star. It drifts through interstellar space, moving through the galaxy on its own trajectory, beholden to no solar system, orbiting only the center of the galaxy itself. These are worlds in the truest sense, with mass and composition similar to the planets we know in our own solar system. But they exist in a fundamentally different context. They are alone. The definition might sound simple, but it actually raises some profound questions about what we even mean when we say the word planet. The International Astronomical Union, the organization responsible for naming and classifying objects in space, has a specific definition for what constitutes a planet. According to their definition, a planet must orbit a star. But if that is true, then what do we call these wandering objects that have all the physical characteristics of a planet, but orbit nothing except the galaxy itself? This is not just a semantic argument. It touches on fundamental questions about how we categorize the objects in our universe and what characteristics truly define a planet. For our purposes, yes, we will consider any object of planetary mass that is not bound to a star to be a rogue planet, regardless of how strictly it fits the technical definition. These objects range in size from bodies potentially smaller than Mars to massive giants that approach 13 times the mass of Jupiter. That upper boundary is important because beyond about 13 Jupiter masses, an object can begin to fuse deuterium in its core, which is the defining characteristic of a brown dwarf, a failed star rather than a planet. So rogue planets occupy this vast range of masses, from small rocky worlds to enormous gas giants, all sharing the common characteristic of stellar isolation. Let me paint a picture for you of what conditions might be like on a typical rogue planet. Imagine the surface of a world that has been drifting through interstellar space for billions of years. The temperature is unimaginably cold, perhaps negative 270 degrees Celsius, just a few degrees above absolute zero, the coldest temperature theoretically possible. At these temperatures, most gases we are familiar with would be frozen solid. If there is an atmosphere at all, it might be a thin layer of frozen nitrogen or other gases, a ghostly shell around a dead world. The darkness is absolute in a way that is difficult for humans to truly comprehend. We have never experienced true darkness. Even on the darkest night on Earth, there is scattered light from stars, from distant cities, from the faint glow of our atmosphere. On a rogue planet, there is nothing. If you were somehow able to stand on the surface and look up at the sky, you would see stars, yes, but they would appear as nothing more than pinpoints of light, no different from any other stars in the sky. None of them would be your sun. None of them would provide warmth. None of them would rise in the morning because there is no morning. There is only the eternal, unchanging night sky of a world that belongs to no star. But here is something fascinating to consider. Not all rogue planets are this cold. Young rogue planets, those that were recently formed or recently ejected from their parent solar systems, can still retain significant internal heat. Some of these young rogues have surface temperatures of several hundred degrees Celsius, glowing faintly in infrared light as they radiate the heat of their formation into the cold void of space. Over billions of years, they will cool, gradually losing their warmth until they reach that near absolute zero temperature of the interstellar medium. But for millions or even billions of years after their birth, they can maintain temperatures that would seem almost hospitable compared to the frozen ancients that have been wandering since near the beginning of the universe. The atmosphere of a rogue planet, if it has one, presents another fascinating area of study. Unlike planets that orbit close to stars, rogue planets do not experience the constant bombardment of stellar wind, that stream of charged particles that flows outward from every star. This stellar wind slowly strips away the atmospheres of planets over billions of years. But rogue planets, isolated from any star, might actually be able to retain their atmospheres more effectively than their star-bound counterparts. A massive rogue planet with a thick hydrogen and helium atmosphere might keep that atmosphere essentially forever, and that atmosphere could play a crucial role in keeping the planet warmer than it otherwise would be. Now let us explore the violent origins of these cosmic wanderers. How does a planet end up alone in the void? The answer, it turns out, is usually violence. The birth of a rogue planet is almost always a story of cosmic drama, of gravitational chaos, of forces so powerful that they can take a world that formed in the warmth of a stellar nursery and fling it out into the cold darkness forever. The most common origin for rogue planets is ejection from a forming solar system. When a solar system is young, it is a chaotic place. Multiple planets are competing for orbital space around their newborn star. The gravitational interactions between these forming planets can be incredibly complex and unpredictable. Imagine a cosmic game of billiards where the balls are entire worlds and the table is the vast expanse of space around a young star. As these protoplanets interact gravitationally, pulling on each other as they orbit, some orbits become unstable. A planet might have a close encounter with a more massive neighbor, a gravitational slingshot that adds energy to its orbit. Over time, through multiple such encounters, a planet can gain enough velocity to escape the gravitational grip of its parent star entirely. This process of gravitational ejection is not rare. Computer simulations of solar system formation suggest that it is actually the norm rather than the exception. Most solar systems probably eject at least one planet during their formative years, and some might eject several. The planets most likely to be ejected are those in the outer reaches of their solar systems, where the gravitational binding to the central star is weakest, and where encounters with other planets can more easily provide the escape velocity needed to break free. Think about our own solar system for a moment. We have 8 planets that we know of, but there might have been more in the past. The early solar system was a far more chaotic place than the orderly arrangement we see today. Computer models of the early solar system, particularly the Nice model named after the French city where it was developed, suggest that our giant planets underwent significant migration in their orbits billions of years ago. Jupiter and Saturn may have moved inward and then outward, their gravitational interactions sending ripples through the entire solar system. During this chaotic period, it is entirely possible that one or more planets that were forming in the outer solar system were ejected entirely, sent careening off into interstellar space to become rogue planets themselves. And here is a tantalizing thought. You may have heard of the hypothetical Planet 9, a large planet that some scientists believe exists in the far outer reaches of our solar system, far beyond the orbit of Neptune. Its existence has been proposed to explain certain strange orbital characteristics of objects in the Kuiper belt. But what if Planet 9 is not a planet that formed with our solar system at all? What if it is a captured rogue planet, a wanderer from the void that drifted too close to our sun and was gravitationally captured into a distant eccentric orbit? The idea is speculative, but it is not impossible. It would represent a profound connection between our orderly solar system and the dark wanderers of interstellar space. But ejection is not the only way rogue planets come into existence. Some of them were never part of a solar system to begin with. They formed alone in the vast molecular clouds of gas and dust that exist throughout the galaxy. The same process that creates stars, the gravitational collapse of dense regions within these clouds, can also create objects that are not quite massive enough to become stars. When a particularly small or dense region of a molecular cloud collapses, it might form an object with a mass in the planetary range rather than the stellar range. These objects are sometimes called sub-brown dwarfs, but they are essentially rogue planets that form directly from the collapse of gas clouds, never knowing the warmth of a parent star because they never had one. This process of direct formation has been confirmed by observations of young rogue planets in star-forming regions. Astronomers have found free-floating planetary mass objects in stellar nurseries, like the Sigma Orionis cluster and the Rho Ophiuchi cloud complex. These objects are so young that they could not possibly have been ejected from a solar system and travelled to their current location. They must have formed where they are found, born into the void rather than cast out into it. There is something almost melancholy about this origin story. At least the ejected rogue planets once knew the warmth of a star, once belonged to a family of planets, once had a home. These directly formed rogues have been alone since the moment of their creation, wanderers from birth with no memory of warmth to look back on. There is yet another pathway to becoming a rogue planet, and it involves the death of stars. When a star reaches the end of its life, it can undergo dramatic transformations. A star like our Sun will swell into a red giant, its outer layers expanding to engulf the inner planets. Eventually, it will shed its outer layers entirely, leaving behind a white dwarf, a stellar remnant with only a fraction of its original mass. More massive stars end their lives in spectacular supernova explosions, blasting their outer layers into space in a catastrophic event of almost unimaginable violence. What happens to the planets orbiting a star that dies? Some of them will be destroyed, consumed by the expanding red giant or vaporized by the supernova blast. But planets in the outer reaches of the solar system might survive. And here is the key point. When a star loses a significant portion of its mass, whether through the gentle shedding of a red giant phase or the violent expulsion of a supernova, its gravitational grip on its remaining planets weakens. A planet that was once securely bound in orbit might find itself on an escape trajectory, gradually spiraling outward and eventually breaking free entirely, says Augusta. These post-stellar death rogues have a particularly poignant origin story. They stayed loyal to their star for billions of years, and when that star died, they were set adrift into the cosmos, orphaned by the death of their parent. Finally, there is the scenario of stellar encounters and gravitational theft. Stars in a galaxy are not fixed in position. They move through the galaxy on their own orbits, and over the billions of years that a solar system exists, close encounters with other stars are inevitable. When two stars pass relatively close to each other, their gravitational fields interact, and planets in the outer reaches of either system can be affected. A planet might be pulled away from its parent star by the gravity of the passing star, just becoming temporarily bound to the intruder before eventually being released into interstellar space. In this scenario, a planet might have multiple owners over its lifetime, being passed from one stellar gravitational well to another, before finally breaking free entirely. It is a cosmic game of catch played over millions of years, with entire worlds as the ball. Now that we understand how rogue planets are born, let us tackle the question of how we actually find them. This is one of the greatest challenges in modern astronomy. How do you find an object that produces no light of its own, that is completely dark against the blackness of space, that could be almost anywhere in the vast expanse between the stars? The answer has required some of the most clever and innovative techniques ever developed in the field of astronomy. The first method that has successfully detected rogue planets is infrared imaging. While rogue planets do not reflect light from a star like the planets in our solar system, young rogue planets still glow with their own internal heat. When a planet forms, whether through the gradual accumulation of material in a protoplanetary disk or through the direct collapse of a gas cloud, the process of formation releases tremendous amounts of energy. This energy heats the planet, and a young rogue planet can have a temperature of hundreds or even thousands of degrees Celsius. As the planet radiates this heat away into space, it glows in infrared light, light that is invisible to our eyes but detectable by specialized telescopes. Space telescopes like WISE, the Wide Field Infrared Survey Explorer, JUSTRI, and the Spitzer Space Telescope have been instrumental in searching for these warm young rogue planets. By surveying the sky in infrared wavelengths, these telescopes can identify objects that are too cold to shine in visible light, but too warm to be completely invisible in the infrared. Through these surveys, astronomers have discovered numerous candidate rogue planets, particularly in and around star-forming regions where young rogues are most likely to be found. But there is an obvious limitation to this method. Only young rogue planets are warm enough to be detected this way. An ancient rogue planet that has been wandering through the galaxy for billions of years, slowly cooling all the while, would have a temperature barely above absolute zero. Such an object would produce essentially no detectable infrared radiation. It would be, for all practical purposes, invisible. And these cold, ancient rogues are likely to be far more numerous than the warm young ones. So how do we find them? The answer lies in one of the most remarkable predictions of Einstein's theory of general relativity, gravitational lensing. According to Einstein, mass warps the fabric of space-time itself. When light from a distant star passes near a massive object, its path is bent by this warped space-time. The massive object acts as a lens, bending and magnifying the light from the distant source. This effect has been observed many times with massive objects like galaxies and galaxy clusters, which can create dramatic arcs and multiple images of background objects. But the same effect occurs on a much smaller scale when a planet-mass object passes in front of a distant star. This is called gravitational microlensing, and it has become the most powerful tool for detecting rogue planets. When a rogue planet happens to pass between us and a distant background star, its gravity acts as a tiny lens, slightly magnifying the light from that star. The result is a brief brightening of the background star, typically lasting from a few hours to a few days, depending on the mass of the lensing object and the geometry of the alignment. The beauty of this method is that it works regardless of whether the lensing object produces any light of its own. A completely cold, dark rogue planet will still bend light by its gravity. The only requirements are that we happen to be looking at the right star at the right time when a rogue planet passes in front of it. This might sound like finding a needle in a haystack, and in many ways it is. The probability of any given star being microlensed at any given moment is incredibly small. But by monitoring millions of stars simultaneously over long periods of time, astronomers can catch these rare events when they occur. Major microlensing surveys like OGLE, the Optical Gravitational Lensing Experiment, and more microlensing observations in astrophysics have been monitoring the dense star fields toward the center of our galaxy for decades. These surveys have detected numerous microlensing events, and careful analysis of these events has allowed astronomers to estimate how many free-floating planetary mass objects exist in the galaxy. The results have been staggering. Based on microlensing data, it appears that rogue planets might indeed outnumber the stars in our galaxy. There is a limitation to microlensing as well, however. Each microlensing event is essentially a one-time occurrence. Once a rogue planet has passed in front of a background star and moved on, we can never observe that same event again. This makes it impossible to study any individual rogue planet in detail using this method. We can determine approximate masses based on the duration and characteristics of the lensing event, but we cannot learn much about the composition, atmosphere, or other properties of the rogue planet itself. It is like catching a glimpse of a shadow moving past your window. You know something was there, but you cannot see what it looked like. Let me tell you about some of the specific rogue planets that astronomers have discovered. One of the most well-studied is an object with the memorable name CFBDSIR 2149472-040308.9, usually mercifully shortened to CFBDSIR 2149. This object was discovered in 2012 and initially generated tremendous excitement because it appeared to be a relatively nearby rogue planet, with a mass of about 4 to 7 times that of Jupiter. Its surface temperature was estimated at about 400 degrees Celsius, warm enough to glow in the infrared and suggesting it is relatively young, perhaps between 50 and 120 million years old. CFBDSIR 2149 appeared to be a member of the AB Doradus moving group, a collection of stars that all form together and are moving through the galaxy in the same direction. If confirmed, this would mean the object formed directly from the same gas cloud that produced these stars, rather than being ejected from a planetary system. Another famous discovery came in 2020 and 2021, when astronomers identified over 70 potential rogue planets in the Upper Scorpius OB stellar association and Ophiuchus star-forming region. This was the largest single discovery of rogue planet candidates to date. The objects ranged in mass from about 4 to 14 Jupiter masses, right at the boundary between planets and brown dwarfs. The sheer number of rogues found in this region suggested that either star formation produces far more planet mass objects than previously thought, or that planetary ejection is far more efficient than our models predicted. On the smaller end of the scale, microlensing surveys have detected objects with masses potentially as low as Earth, or even smaller. These detections are more uncertain because the microlensing signal from such small objects is weaker and harder to distinguish from noise. But if confirmed, they would demonstrate that rogue planets span the full range of planetary masses, from tiny rocky worlds to massive gas giants. The galaxy might be full of wandering Earths, frozen worlds the size of our own planet that formed and were ejected from their parent systems, now drifting alone through the void. Now, let us explore a fascinating question. Can rogue planets have moons? The answer, perhaps surprisingly, is almost certainly yes. When a planet is ejected from its parent solar system, there is no reason it would necessarily lose any moons it might have. The gravitational binding between a planet and its close orbiting moons is very strong, much stronger than the binding between that planet and its distant parent star. An ejection event that imparts enough velocity for a planet to escape its star's gravity might not be enough to strip away the moons that are nestled close to the planet itself. Think about the moons in our own solar system. Jupiter has dozens of moons, including the 4 large Galilean moons that are worlds in their own right. Saturn, Uranus, and Neptune also have extensive moon systems. If any of these giant planets were somehow ejected from our solar system, they would almost certainly take at least some of their moons with them. The ejected planet would sail off into the darkness accompanied by a retinue of smaller bodies, a miniature solar system without a sun, with the planet itself providing the central gravitational anchor. This possibility becomes especially interesting when we consider the potential for habitability. We know from our own solar system that some moons of gas giant planets have conditions that might be suitable for life. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn, both appear to have liquid water oceans beneath their icy surfaces. The heat that maintains these oceans does not come from the sun, which is far too distant to provide significant warmth to these outer solar system bodies. Instead, the heat comes from tidal forces. As these moons orbit their parent planets, the gravitational pull of the planet flexes and stretches them, generating heat through friction in their interiors. This tidal heating can be powerful enough to maintain liquid water, even in the frozen outer reaches of a solar system. Now imagine a rogue gas giant drifting through interstellar space, with a Europa-like moon orbiting it. The moon still experiences tidal heating from its orbital motion around the planet. The liquid ocean beneath its surface is still there, maintained not by a distant sun but by the gravitational relationship between moon and planet. That ocean could potentially persist for billions of years, providing a stable environment where life might arise and evolve. The rogue planet system would be a tiny oasis of liquid water and chemical energy drifting through the cosmic desert, a potential home for life in the most unlikely of places. We have not yet detected any moons around rogue planets, but this is likely due to the extreme difficulty of making such a detection rather than the absence of such moons. If the rogue planet itself is barely detectable, a smaller moon orbiting it would be even harder to find. Future space telescopes and improved detection techniques might eventually confirm the existence of rogue planet moon systems, and if they do, it will open up an entirely new chapter in our understanding of where life might exist in the universe. Let us push this idea even further. What if two rogue planets could orbit each other? Binary planet systems, where two planets of similar mass orbit a common center of gravity, are theoretically possible. We have found binary brown dwarf systems and binary asteroid systems, so there is no fundamental reason why binary planets could not exist. Such a system might form if two planets were ejected from the same solar system at similar velocities and managed to capture each other gravitationally. Or it might form directly from a fragmenting gas cloud that produced two planetary mass objects in close proximity. A binary rogue planet system would be a strange and wonderful thing. Two worlds, each the size of Jupiter or larger, slowly orbiting each other as they drift through interstellar space. If they were close enough, they might even exchange material, with gases from one atmosphere being drawn toward the other. If both planets had moons, the gravitational dynamics would become incredibly complex, and if the two planets were similar in mass, they might raise significant tides on each other, potentially generating internal heat through tidal friction. It is a scenario that sounds like science fiction, but it is entirely consistent with the laws of physics, and it might be happening right now somewhere in our galaxy. Now we come to what might be the most profound question about rogue planets. Can there be life on a world that has never known a sun? This question challenges everything we think we know about the conditions necessary for life to exist. For decades, the concept of the habitable zone has dominated our thinking about where to look for life in the universe. The habitable zone, sometimes called the Goldilocks zone, is the region around a star where temperatures are just right for liquid water to exist on a planet's surface. Not too hot, not too cold, but just right. Earth sits comfortably within our sun's habitable zone, and the search for life on other worlds has largely focused on finding planets that orbit within the habitable zones of their stars. But rogue planets have no star. They have no habitable zone in the traditional sense. Does that mean they cannot support life? An increasing number of scientists are saying not so fast. The traditional conception of the habitable zone might be far too narrow. It might represent a failure of imagination, an assumption that life must exist the way it does on Earth, dependent on the light and warmth of a star. What if life can arise and thrive using completely different energy sources? Consider the deep biosphere of Earth itself. We tend to think of life on our planet as being concentrated at the surface, basking in the warmth of the sun and powered by photosynthesis. But life extends far deeper than that. Bacteria have been found living in rocks kilometers below the Earth's surface, in environments with no sunlight at all. These microbes derive their energy not from the sun but from chemical reactions, CFBDSIR. Using the heat and chemistry of Earth's interior to power their metabolism. The deep biosphere might contain as much biomass as the entire surface ecosystem, and it exists completely independently of sunlight. Now think about what this means for rogue planets. A rogue planet would have no sunlight reaching its surface, but it would still have internal heat. Radioactive decay in the planet's interior would provide a steady trickle of energy, just as it does in Earth. This radioactive decay is powered by long-lived isotopes like uranium, thorium, and potassium, which release energy as they slowly break down over billions of years. The heat from this decay keeps Earth's core molten and drives the geological activity that shapes our planet's surface. A rogue planet would have the same processes occurring, providing a source of energy completely independent of any star. Beyond radioactive decay, a massive rogue planet would still retain significant heat from its formation. Remember that planet formation is an energetic process. The collapse of gas and dust, the accretion of material, the differentiation of a planet's interior into distinct layers, all of these processes release enormous amounts of heat. A large planet can take billions of years to cool down, radiating that primordial heat slowly into space. For a gas giant rogue, this primordial heat might be enough to maintain relatively warm temperatures in its deep atmosphere or interior for an incredibly long time. And if the rogue planet has moons, we have already discussed the tidal heating mechanism that could maintain liquid water oceans. But even without moons, there is another way a rogue planet might maintain liquid water. A sufficiently thick hydrogen atmosphere can act as an incredibly effective insulator. Hydrogen is a poor radiator of heat, meaning that a planet with a dense hydrogen atmosphere would lose its internal heat very slowly. Models have shown that an Earth-sized planet with a hydrogen atmosphere, just a few times thicker than Earth's nitrogen-oxygen atmosphere, could maintain surface temperatures above the freezing point of water, even in the complete absence of a star. Liquid water could exist on the surface of such a world, not through external heating from a sun, but through the retention of internal heat by an insulating atmospheric blanket. Let me describe a scenario for how life might exist on a rogue planet. Picture a world similar to Europa, an icy moon orbiting a rogue gas giant. The surface is frozen solid, a shell of ice perhaps kilometers thick covering the entire world. But beneath that ice, kept warm by the constant flexing of tidal forces, is a liquid water ocean. This ocean has existed for billions of years and will continue to exist for billions more. At the bottom of this ocean, where the water meets the rocky core of the moon, hydrothermal vents pump hot, mineral-rich water into the darkness. These vents are powered by the same tidal heating that maintains the ocean, creating localized hotspots of chemical energy on the ocean floor. Now imagine what might evolve in such an environment. On Earth, the deep ocean hydrothermal vents support complex ecosystems completely independent of sunlight. Giant tube worms, strange shrimp, and mats of bacteria cluster around these vents, deriving energy from the chemical reactions between the hot vent fluid and the cold ocean water. The base of this food chain is chemosynthesis, where bacteria use the energy of chemical reactions rather than sunlight to produce organic molecules. Could similar ecosystems exist on the moon of a rogue planet? There is no fundamental reason why not. The chemistry of life, as we understand it, requires liquid water, energy, and the right chemical building blocks. A rogue planet moon with a subsurface ocean heated by tidal forces would have liquid water. Hydrothermal vents would provide energy and chemical building blocks. All the ingredients are there. The only question is whether life would actually arise under such conditions, and that is a question we cannot yet answer. But the possibility is real enough that some scientists consider rogue planets and their moons to be legitimate targets in the search for extraterrestrial life. What might life look like if it evolved on a rogue planet? Here we enter the realm of speculation, but informed speculation based on what we know about life on Earth and the conditions that would exist on a rogue planet. First, any life on a rogue planet would almost certainly be microbial. Complex multicellular life requires enormous amounts of energy to sustain, and the energy available on a rogue planet would be limited compared to a world basking in the output of a star. Bacteria and archaea, simple single-celled organisms, are much more efficient at extracting energy from their environment and could plausibly survive on the meager energy budget of a rogue world. These microbes would be chemosynthetic, deriving their energy from chemical reactions rather than light. They might cluster around hydrothermal vents or other sources of chemical energy, forming microbial mats or biofilms similar to those found in Earth's deep subsurface. They would be adapted to cold, high-pressure environments, tolerating conditions that would be instantly fatal to most familiar life forms. In short, they would be extremophiles, organisms that thrive in conditions at the extreme limits of what life can tolerate. But could complex life evolve on a rogue planet? This is more doubtful, but perhaps not impossible. On Earth, complex life took billions of years to evolve, and it required the enormous energy input of sunlight to support the food chains that sustain large organisms. A rogue planet would not have this energy input, so the evolution of complex life would face serious obstacles. However, if a rogue planet moon had sufficiently productive hydrothermal vents and stable conditions for billions of years, it is conceivable that simple life could gradually evolve greater complexity. We simply do not know enough about the requirements for the evolution of complex life to rule it out entirely. And here is a truly mind-bending possibility. What if life did not have to evolve on the rogue planet at all? What if it was seeded from elsewhere? The hypothesis of panspermia suggests that life might be able to spread between worlds, carried by meteorites or other debris ejected from living planets. If this hypothesis is correct, a rogue planet passing through a solar system that harbored life might be able to pick up microbial hitchhikers. These microbes, sheltered in the subsurface ocean of a rogue planet moon, could then be carried across the galaxy as the rogue continues on its journey. The rogue planet becomes a kind of cosmic seed ship, spreading life through the universe over billions of years. If this sounds far-fetched, consider the numbers involved. If there are truly hundreds of billions of rogue planets in our galaxy, and if even a small fraction of them have conditions suitable for preserving life, then the galaxy could be full of these cosmic arcs. Over the 14 billion-year history of the universe, these rogues would have had countless opportunities to pass through the habitable zones of stars, to encounter other rogue planets, here to exchange material through meteorite impacts. The network of potential connections is vast beyond imagining. Now let us consider a scenario that brings the concept of rogue planets much closer to home. What if a rogue planet were to enter our own solar system? This is not just idle speculation. It has almost certainly happened before in the history of our solar system, and it will almost certainly happen again. The question is when and what the consequences might be. First, let us consider whether we would even see it coming. The answer is deeply unsettling. Maybe not. A dark, cold, rogue planet approaching our solar system from the depths of interstellar space would be extremely difficult to detect until it got relatively close. We have surveys watching for near-Earth objects like asteroids and comets that might pose an impact threat, but these surveys are optimized for detecting small, fast-moving objects relatively close to Earth. A rogue planet approaching from far outside our solar system would be moving slowly relative to the background stars and would produce no light of its own. By the time it got close enough for its gravitational effects to be noticeable, it might already be entering the outer reaches of our solar system. What would happen if a rogue planet did enter our solar system? The answer depends entirely on the mass of the rogue, its trajectory, and how close it comes to our existing planets. If it passed through the outer reaches of our solar system, through the Kuiper Belt and beyond, its gravitational influence might send some of those distant icy bodies tumbling inward. A shower of comets might rain through the inner solar system, increasing the chance of impacts on Earth and other planets. We have evidence that such comet showers might have occurred in the past, potentially linked to the passage of stars or massive objects through the outer solar system. If the rogue planet came closer, passing through the realm of the giant planets, the effects could be much more dramatic. The gravitational interactions between a massive rogue and our existing gas giants could alter their orbits, potentially destabilizing the entire solar system. In a worst-case scenario, a rogue massive enough and passing close enough could send one of our own planets careening into a different orbit, potentially setting off a chain reaction of gravitational chaos. The stable arrangement of planets we have known for billions of years could be thrown into disarray. And if a rogue planet came close enough to the inner solar system, close enough to Earth, the effects would depend on how close the encounter was. A distant passage might cause significant but survivable disruptions, pulling Earth's orbit into a slightly different shape, perhaps increasing the eccentricity so that our seasons became more extreme. A closer passage could be catastrophic, fundamentally altering Earth's orbit to the point where our planet was no longer habitable. In the most extreme scenario, Earth itself could be ejected from the solar system, becoming a rogue planet in its own right, our atmosphere freezing solid, our oceans turning to ice, our civilization ending as our world drifted off into the eternal darkness. It is important to emphasize that such a close encounter is extremely unlikely on human timescales. The distances between stars are vast, and even though stars occasionally pass relatively close to our solar system, the chances of a rogue planet being on a collision course with our solar system at the right time and trajectory are astronomically small. We face far more immediate threats from asteroids and comets already in our cosmic neighborhood. But over geological timescales, over millions and billions of years, close encounters with rogue planets become much more likely. Our solar system has probably experienced several such encounters in its 4.5 billion year history, and it will experience more in the future. There is an intriguing historical case to consider. About 70,000 years ago, a small red dwarf star called Schultz's star, accompanied by a brown dwarf companion, passed through the outer reaches of our solar system. It came within about 52,000 astronomical units of the Sun, passing through the outer Oort cloud, the distant halo of icy bodies that surrounds our solar system. This is relatively close by cosmic standards. The gravitational influence of this passage might have sent some Oort cloud objects tumbling toward the inner solar system, potentially contributing to the population of long-period comets we see today. If a small star can pass this close, a rogue planet certainly could as well. We might never know about such a passage until long after it occurred, detecting its effects only through careful analysis of the orbits of distant solar system objects. Astronomers are currently searching for evidence of past planetary encounters in the orbital characteristics of Kuiper belt objects and other distant bodies. Some of the orbital oddities we observe might be the signatures of past rogue planet flybys, though proving this would be extremely difficult. Now let us take a moment to consider what it would be like to experience existence as a rogue planet. This is, of course, an exercise in imagination rather than science, but it can help us appreciate the true strangeness of these cosmic wanderers. Imagine you are standing on the surface of a rogue planet. It is a rocky world, perhaps similar in size to Earth, that was ejected from its parent solar system billions of years ago. The surface is frozen solid, a barren landscape of ice and rock that stretches endlessly in every direction. There is no wind because the atmosphere, if there ever was one, has long since frozen out, leaving only a thin haze of sublimating gases. The silence is absolute. There is no sound because there is no atmosphere to carry it. You're in the most complete silence imaginable. Above you, the sky is black, but it is not empty. Stars fill the darkness, the same stars you would see from Earth, but without the familiarity of any particular sun being yours. The Milky Way stretches across the sky in all its glory, perhaps even more brilliant than it appears from Earth, because there is no atmosphere to scatter its light. But this beauty is cold comfort, literally. The temperature around you is nearly 300 degrees below 0 Celsius, cold enough that most gases would be solid at your feet. The only light that reaches you is the faint glow of distant stars, not enough to see by in any meaningful way. You're in darkness, true darkness, the kind of darkness that humans never experience on Earth. Now imagine the loneliness. There is nothing around you for light years. The nearest star is so distant that light from it, traveling at 300,000 kilometers per second, would take years to reach you. The nearest planet might be similarly far away. In the entire visible universe from your vantage point, you are the only world, drifting through an emptiness so vast that your human mind cannot truly grasp it. You have been drifting for billions of years, and you will continue drifting for billions more. There is no destination. There is no journey's end. There is only the eternal voyage through the cosmic void. And yet, even here, there might be warmth. Deep beneath the frozen surface in the rocky core of this wandering world, radioactive elements are still decaying, releasing their energy as heat. If this rogue planet is large enough, if it retained enough primordial heat from its formation, there might be liquid water somewhere deep underground. warm water circulating through cracks in the rock, carrying nutrients and energy. And in that water, against all odds, there might be life. Simple microbial life, perhaps, feeding on the chemical energy seeping from the rocks, completely unaware of the frozen desolation on the surface above, completely unaware that their entire world is wandering alone through the darkness. They simply live, as life does, wherever it can find the conditions to persist. This is the profound strangeness of rogue planets. They are worlds that challenge our assumptions about what a planet should be and where life should exist. They remind us that the universe does not care about our definitions or our expectations. It creates worlds in all possible configurations, including configurations we might never have imagined. The future of rogue planet science is incredibly exciting. We are on the verge of discoveries that could revolutionize our understanding of these cosmic wanderers. Several major telescopes and missions coming online in the next few years will dramatically improve our ability to detect and study rogue planets. The Nancy Grace Roman Space Telescope, scheduled to launch in the coming years, will conduct extensive microlensing surveys that could detect thousands of rogue planets across a wide range of masses. By monitoring the dense star fields toward the center of our galaxy, Roman will catch the telltale signature of rogue planets passing in front of distant stars, allowing us to build a much more accurate census of the rogue planet population. We will finally be able to answer questions like how many rogue planets exist in our galaxy, what is the distribution of their masses, and are there truly more rogues than stars? The Vera C. Rubin Observatory, with its unprecedented ability to survey the entire visible sky every few nights, will also contribute to rogue planet science. Its rapid all-sky coverage will allow it to detect microlensing events in real time, potentially alerting other telescopes to observe these events while they are still occurring. The Rubin Observatory will also be sensitive to the slow motion of nearby rogue planets against the background stars, a technique called astrometry that could reveal rogues that are too cold to detect by other means. The European Space Agency's Euclid mission will add another dimension to our understanding of rogue planets. Originally designed to study dark energy and dark matter, Euclid will also conduct microlensing surveys that complement those of other observatories. The combination of data from multiple missions will allow scientists to cross-check their results and improve the accuracy of their rogue planet census. And the James Webb Space Telescope, already revolutionizing astronomy with its unprecedented infrared sensitivity, has already contributed to rogue planet science and will continue to do so. Webb can study known rogue planet candidates in unprecedented detail, analyzing their atmospheres and temperatures to understand their compositions and histories. For the first time, we may be able to study individual rogue planets as worlds in their own right, rather than just statistical blips in microlensing data. The ultimate dream, of course, would be to visit a rogue planet. This is far beyond our current technological capabilities, but it is worth considering what such a mission might look like. The first challenge would be finding a rogue planet close enough to reach in a reasonable time frame. If there is indeed a rogue planet within a few light years of Earth, as some estimates suggest, it might be a feasible target for a probe traveling at a significant fraction of the speed of light. Concepts like light sails accelerated by powerful lasers, currently being explored by the Breakthrough Starshot initiative, could potentially reach such a target within decades rather than millennia. A probe arriving at a rogue planet would find a world like nothing we have ever explored. No sunlight to power solar panels, so the probe would need nuclear power sources, extreme cold requiring specialized materials and heating systems, and the challenge of communicating back to Earth across light years of distance, with signals taking years to travel each way. It would be the most challenging space mission ever attempted, but the scientific payoff would be immense. We would finally know what these lonely wanderers are really like, whether they have moons, whether they have liquid water, whether they might harbor life. As we contemplate the future of rogue planet exploration, we should also consider the long-term future of rogue planets themselves. In the grand sweep of cosmic time, rogue planets may actually have the last laugh over their starbound cousins. Stars do not last forever. Even the longest-lived red dwarf stars will eventually exhaust their fuel and fade into darkness, taking their planetary systems with them into obscurity. But rogue planets are already in that darkness. They have already adapted to existence without a star. They will continue wandering through the cosmos long after the last stars have burned out. In the far future, trillions of years from now, When the universe is cold and dark and all the stars have died, the rogue planets will still be there, drifting through the void as they always have, unchanged by the death of the stellar era. If any life exists on these rogues huddled around their internal heat sources, it might be the only life left in the universe. The ultimate survivors, the children of darkness, outliving the light itself. There is something poetic about this. The planets that were cast out, the worlds that never belonged, might be the ones that endure longest. Their isolation, which seems so tragic from our sun-warmed perspective, might actually be their salvation. They do not depend on the temporary gift of stellar light. They carry their energy with them, locked in their interiors, radiating slowly into the void. They are self-sufficient in a way that starbound planets can never be. What does this mean for us, sitting on our comfortable Earth, warmed by our reliable sun? Perhaps it means we should be humble about our place in the cosmos. We think of our solar system as home, as stable, as eternal. But it is none of these things. Our sun will die in about 5 billion years, and long before that its increasing luminosity will make Earth uninhabitable. Our future as a species, if we survive that long, lies in the stars, and perhaps, just perhaps, our distant descendants will one day call a rogue planet home. A wandering world engineered for habitability, carrying human civilization through the dark spaces between the stars. This is not just idle fantasy. Some scientists have seriously proposed that rogue planets could serve as waypoints for interstellar travel. A civilization attempting to cross the vast distances between stars might find it useful to stop at rogue planets along the way, using their resources to refuel and resupply. The rogues would be like cosmic oases in the desert of interstellar space, allowing travelers to rest before continuing their journey. If rogue planets are as common as we now believe, the space between stars might not be as empty as it seems. It might be dotted with these dark waypoints, waiting to be discovered and utilized by future explorers. We began this journey with a question: what if there are planets out there that are completely alone? We have now explored that question from every angle. We have learned that such planets not only exist, but may outnumber the stars themselves. We have learned how they form, how we detect them, what they might be like. We have considered whether they might harbor life, and whether they might one day be visited by explorers from Earth. And we have seen how they fit into the grand narrative of the cosmos, from the violence of their birth to the cold eternity of their future. What have we learned from this exploration? Perhaps the most important lesson is that the universe is far more diverse and strange than we might have imagined. Our experience on Earth, orbiting a stable sun, enjoying regular days and nights, experiencing seasons and weather driven by stellar energy, is just one way for a world to exist. There are billions of other worlds out there that exist completely differently, in conditions so alien that we can barely imagine them. And yet, even these alien worlds follow the same laws of physics, formed from the same elements, and might even host the same miracle of life that we find on Earth. Rogue planets remind us that home is a relative concept. For us, Ascoacids, home is a planet warmed by a sun. For a rogue, home is the void itself. Neither is more natural or more valid than the other. They are simply different expressions of the cosmic processes that create worlds. These wandering worlds also remind us of the vastness of what we do not know. For every rogue planet we have detected, there are likely millions more that we have not. For every question we have answered about these objects, there are dozens more that remain mysterious. We do not know how many of them have moons. We do not know how many might have liquid water. We do not know if any of them harbor life. These are questions for future generations of scientists to answer, using tools and techniques that have not yet been invented. And perhaps most profoundly, rogue planets remind us of our own cosmic insignificance and significance simultaneously. Insignificance because there are so many worlds out there, so many possibilities, that our little Earth is just one among trillions. But significance because we are the ones asking these questions, the ones seeking to understand the cosmos, the ones who might one day reach out and touch these distant wanderers. In all the universe, on all the billions of rogue planets drifting through the darkness, there may be no other beings contemplating their existence as we are right now. So the next time you look up at the night sky, remember that between those points of light, in the dark spaces where you see nothing at all, there are worlds, billions of worlds, wandering alone, carrying their secrets through the cosmic void. They have been traveling since before Earth existed, and they will continue traveling long after Earth is gone. They are the rogue planets, the cosmic orphans, the lonely wanderers of the darkness. And who knows? Perhaps on one of those dark worlds, deep beneath a frozen surface, in a liquid ocean warmed by the flexing of tidal forces, something is alive. Something that has never seen a sunrise, never felt the warmth of a star, never known anything but the darkness and the cold. Something that is, in its own way, just as miraculous as life on Earth. Something that proves that life can find a way, even in the most unlikely places, even in the eternal night of a rogue planet wandering alone in darkness. The universe is full of wonders we have not yet discovered, questions we have not yet asked, and answers we cannot yet imagine. Rogue planets are just one example of how reality exceeds our expectations, how nature is more creative than our theories, how the cosmos continues to surprise us no matter how much we learn. This is why we explore. This is why we ask questions. This is why we look up at the sky and wonder what is out there. Thank you for joining me on this journey into the darkness. The exploration does not end here. Every day, astronomers around the world are learning more about rogue planets and all the other wonders of the universe. New discoveries await, new mysteries will be revealed, and new questions will emerge. The cosmos is an endless frontier, and we are just beginning to explore it. If you found this journey fascinating, if the idea of these lonely wandering worlds captured your imagination as it has captured mine, then I encourage you to keep exploring, keep asking questions, keep looking up. The universe is waiting to be discovered, and there is so much more to learn. This is just the beginning of a much larger adventure, an adventure that humanity has been on since we first looked up at the stars and wondered what they were. The rogue planets are out there right now as you read these words. They are drifting through the darkness between the stars, carrying their mysteries with them. Some of them are older than our solar system, some of them might be closer than we know, and some of them perhaps might harbour secrets that would change everything we think we know about life in the universe. One day we may find out. One day we may send a probe to a rogue planet and see for ourselves what these worlds are like. One day, we may discover that we are not alone in the universe, and that discovery might come not from a planet orbiting a distant star, but from a wanderer in the darkness, a rogue planet that has been drifting through the cosmos since the universe was young. Until then, we will keep searching. We will keep asking questions. We will keep pushing the boundaries of what we know. Because that is what humans do. We explore, we discover, we seek to understand, and in doing so, we find our own place in the vast and wondrous cosmos. The darkness between the stars is not empty. It is full of worlds we have not yet found, waiting to be discovered. And every one of those worlds has a story to tell. The story of the rogue planets is one of violence and loneliness, of cold and darkness, but also of resilience and endurance. They have survived being cast out from their homes. They have survived billions of years of wandering through the void, and they will survive long after the stars themselves have faded. There is a lesson in that survival, a lesson about the persistence of existence in a universe that often seems hostile to it. Life finds a way, worlds endure. The cosmos, for all its vastness and cold indifference, is a place where remarkable things happen. Rogue planets are one of those remarkable things. And as long as there are beings like us to wonder about them, their story will continue to unfold. In the end, perhaps the rogue planets are not so lonely after all. They are part of the same cosmic story that we are, formed from the same elements, governed by the same laws, participants in the same grand experiment of existence. We are all, in a sense, wanderers in the cosmos, drifting through time and space on our various journeys. The rogue planets have simply taken that wandering to its ultimate extreme, travelling the longest roads, crossing the darkest spaces, enduring the coldest nights. They are the ultimate explorers of the universe, visiting regions of space that no star-bound planet will ever see. And in that sense, they are our kindred spirits, fellow travellers in the infinite night. We share the same universe with them, breathe atoms that might once have been part of a rogue planet's atmosphere, and wonder about the same cosmic questions. So here is to the rogue planets, the cosmic orphans, the wanderers of the void. May we one day know them better. May we one day understand their secrets. And may we always remember that in the darkness between the stars, wonders are waiting to be found. The universe is vast and full of mysteries, The rogue planets are just one of those mysteries, but they are a profound one. They challenge our assumptions about what a world should be and where life might exist. They expand our horizons beyond the comfortable confines of our own solar system. They remind us that the cosmos is far stranger and more wonderful than we might have imagined. As we continue to develop new technologies and push the boundaries of observation, we will discover more and more about these fascinating objects. We will refine our estimates of how many exist. We will learn more about their compositions and structures. We may even discover one close enough to study in detail, or eventually to visit. The future of rogue planet science is bright, and even if the objects themselves exist in eternal darkness. The coming decades will bring revolutionary advances in our understanding of these cosmic wanderers. New telescopes will find new rogues, new techniques will reveal new details, and each discovery will add another piece to the puzzle, helping us understand not just rogue planets themselves, but the broader processes of planet formation and evolution that shape worlds throughout the universe. We stand at a remarkable moment in the history of astronomy. For the first time, we have the tools to detect and study planets that exist outside any solar system, worlds that previous generations could not even have imagined. This is a privilege and a responsibility. We are the first humans ever to know that rogue planets exist, the first to ask serious scientific questions about them, and the first to speculate about whether they might harbour life. Future generations will look back on this time as the beginning of a new era in planetary science. What will they discover? We cannot know for certain, but we can make educated guesses based on what we have learned so far. They will probably find that rogue planets are even more common than we currently believe. They will probably discover that some rogues have extensive moon systems, perhaps even moons with liquid water oceans. They may find chemical signatures in the atmospheres of rogues that hint at biological processes. And perhaps, if we are very lucky, they will find definitive evidence that we are not alone in the universe, and that evidence will come from one of these dark wanderers. This is the promise of rogue planet research. Not just academic knowledge about obscure astronomical objects, but potentially transformative insights into the nature of life and our place in the cosmos. The rogue planets may hold answers to some of the deepest questions humans have ever asked. Where does life come from? How common is it in the universe? Could it exist in places we never expected? These are the questions that drive us to explore, that keep us searching for new discoveries, that make astronomy one of the most exciting fields of human endeavour. And rogue planets sit at the intersection of all these questions, mysterious objects that challenge our understanding and promise new revelations. So let this not be the end of your exploration, but the beginning. Go out and learn more about rogue planets. Read the scientific papers, follow the news of new discoveries. Think about what it would mean if we found life on one of these dark worlds. Imagine what it would be like to send a probe to a rogue planet and see its surface for the first time. Let your imagination roam as freely as the rogues themselves roam through the galaxy. The universe is calling, the darkness is full of wonders, and somewhere out there a rogue planet is wandering alone, carrying secrets we have not yet dreamed of. We are connected to these distant wanderers in ways we might not immediately appreciate. The atoms that make up our bodies were forged in the hearts of stars and scattered through space when those stars died. Some of those atoms may have spent time on a rogue planet before eventually finding their way to Earth. The same processes that created our solar system also created the rogues that were ejected from it. We are all products of the same cosmic machinery, the same stellar nurseries, the same galactic dynamics. When we study rogue planets, we are studying a different outcome of the same processes that made our own world. We are seeing what could have happened to Earth if circumstances had been slightly different, if a gravitational encounter had sent us tumbling out into the void instead of keeping us safely in orbit around our sun. In studying the rogues, we come to understand our own origins more deeply. And when we ask whether there could be life on rogue planets, we are really asking a deeper question about the nature of life itself. Is life something that can only happen in very specific conditions, or is it something that emerges wherever conditions are even marginally suitable? The answer to that question has profound implications for our understanding of the universe and our place in it. If life can thrive on rogue planets, then it can probably thrive in many other places we have not yet considered. The universe might be teeming with life in forms and places we cannot yet imagine. This is the true significance of rogue planet research. It is not just about understanding these particular objects, as fascinating as they are, It is about understanding the full range of possibilities for worlds and for life in our universe. It is about pushing back the boundaries of our ignorance and expanding the horizons of our knowledge. It is about being humble enough to recognize that we have not yet imagined all the ways existence can manifest. The cosmos has been here for nearly 14 billion years, and in that time, it has created wonders beyond counting. Rogue planets are just one of those wonders, but they are a particularly compelling one. They represent the universe's ability to create worlds even in the most unexpected circumstances, to form objects that defy our assumptions, to hide secrets in the darkness between the stars. We are fortunate to live in an age when we can study these objects, when we have the technology to detect them and the scientific framework to understand them. Previous generations knew nothing of rogue planets. They looked up at the night sky and saw only the stars, unaware of the countless dark worlds drifting between them. We know better now. We know that the darkness is populated, that the void is not empty, that worlds exist where no sun shines. This knowledge is a gift, but it is also a responsibility. We must continue to explore, to ask questions, to seek understanding. The rogue planets are waiting to reveal their secrets, and we must be ready to receive them. Every new discovery about these objects adds to our collective knowledge, helps us build a more complete picture of the universe we inhabit. The story of the rogue planets is still being written. We're in the early chapters, still establishing the basic facts, still mapping out the territory. Future chapters will bring new discoveries, new insights, new revelations. We do not know what those chapters will contain, but we know they will be exciting. The universe always surprises us, and rogue planets are no exception. So as we conclude this exploration, let us carry with us the sense of wonder that these objects inspire. Let us remember that there are billions of worlds out there that we have not yet found, each one with its own story. Let us appreciate the remarkable achievement of human science that allows us to detect and study objects so dark and distant. And let us look forward to the discoveries yet to come, the secrets yet to be revealed, the questions yet to be answered. The rogue planets are out there, wandering alone in darkness, but they are not forgotten. We know they exist. We are searching for them, and one day we will understand them far better than we do today. That is the promise of science, the gift of exploration, the reward for never stopping asking questions. In the darkness between the stars, wonders await. The rogue planets are some of those wonders, and they have much to teach us. About planet formation, about the dynamics of solar systems, about the conditions necessary for life, about the full range of possibilities in our vast and ancient universe. This has been a journey into that darkness, a glimpse at those wandering worlds, but every journey has an end, and this one must conclude. As we part ways, I hope you carry with you a new appreciation for these cosmic orphans, a sense of wonder at their existence, and a curiosity about what future discoveries will reveal. The universe is magnificent in its scope and variety. The rogue planets are testament to that magnificence, worlds that exist in conditions we once thought impossible, carrying on their solitary journeys through the cosmic void. They have been traveling for billions of years. They will continue for billions more. And as long as there are beings who wonder about the universe, their story will continue to fascinate and inspire. Thank you for taking this journey with me. Thank you for your curiosity, your attention, and your willingness to explore the unknown. The cosmos rewards those who seek to understand it, and the rogue planets are just one of the many rewards waiting to be claimed. Keep looking up, keep asking questions, keep exploring. The darkness is full of light we have not yet seen, full of worlds we have not yet found, full of wonders we have not yet imagined. And somewhere out there, a rogue planet is wandering alone, waiting for us to discover it. The story does not end here. It continues with every new discovery, every new observation, every new question asked. The rogue planets are part of the ongoing narrative of cosmic exploration, a narrative that we are all participants in. By seeking to understand them, we become part of their story, and they become part of ours. The eternal night of the rogue planets is not an ending, but a beginning of new questions, new explorations, new understandings. The darkness they inhabit is the same darkness that covers half our Earth each night, the same darkness through which light travels to bring us knowledge of distant worlds. It is not an enemy to be feared, but a frontier to be explored, and so we explore. We send our instruments into the darkness, seeking the faint signatures of these wandering worlds. We build our theories and test them against observation. We ask questions we could not have imagined asking a generation ago. We push forward into the unknown, driven by the same curiosity that has driven humanity since our ancestors first looked up at the stars and wondered what they were. The rogue planets are part of that wondering now. They're objects of scientific study, yes, but they're also objects of philosophical contemplation. What does it mean to be a world without a sun? What does it mean to wander alone through the cosmos for billions of years? What might exist on such a world, and what might it think about its existence? These are questions without easy answers, perhaps without any answers at all. But the asking of them is valuable in itself. It expands our minds, broadens our perspectives, and reminds us that the universe is far larger and stranger than our everyday experience suggests. The rogue planets do not care that we wonder about them. They continue on their journeys regardless of our observations and theories. But our wondering matters to us. It makes us more than we would be otherwise. It connects us to something larger than ourselves. It gives meaning to our existence as curious, exploring beings in a vast and mysterious cosmos. So let us keep wondering. Let us keep exploring. Let us keep seeking the secrets of the rogue planets and all the other wonders of the universe. The darkness is vast, but our curiosity is equal to it. The distances are immense, but our determination is greater. The questions are profound, but our minds are capable of grappling with them. The rogue planets wandering alone in darkness are no longer alone in one sense. They have us, watching from afar, wondering about their nature, seeking to understand their stories. And in our wondering, we give them a kind of companionship across the light years, a connection between dark wanderer and distant observer, united by the laws of physics and the curiosity of the human mind. This is the true wonder of astronomy, not just the objects we study, but the fact that we study them at all. That beings on a small rocky planet orbiting an ordinary star in an unremarkable corner of the galaxy can look out into the vastness and seek to understand it. That we can detect planets we will never visit, analyze atmospheres we will never breathe, and imagine life we may never meet. The rogue planets are part of this great adventure. They are chapters in the story of cosmic exploration, waiting to be read. And every discovery we make about them adds to our understanding, not just of these particular objects, but of the universe as a whole. As this journey concludes, the real journey continues. The rogue planets keep wandering, the scientists keep searching, the universe keeps revealing its secrets, one discovery at a time, and somewhere out there, in the darkness between the stars, a rogue planet drifts alone, carrying secrets we have not yet discovered, waiting for the day when human curiosity reaches out to touch it. That day will come. It may be decades or centuries away, but it will come, because that is what humans do. We explore, we discover, we seek to understand, and no darkness, no distance, no difficulty can stop us from pursuing the wonders of the cosmos. The rogue planets wandering alone in darkness are calling to us across the void, and we are listening. End.